Good evening again. First, I have to apologize for the students who generally join on YouTube. Right? I've been here for the longest while, and I kind of lost focus because I was trying to get the lighting to be so that we would not have this bright glare on the screen. The bright glare that has the potential to cause some of the information on the board to be obscure. All right, so what I'm going to do here, I think that we have some, let's see if it is for real, where we have some, the light reflecting off the books and papers. I hope this is one of them, that if I remove this, I will see a difference. No, because it's not on that side. All right. So let us put this all the way over here. There quite to be a lot of spots right there. Trying to figure out where some of these are from and to remove them. Oh, this is nice. Paper one like this. Right. Disaster is about to strike over that side, but let's see what happens. I'm going to fix it. Nonetheless, when we have the opportunity, I'm going to go back up there. Now, yes, now, I'm going to be watching that as it comes down, and I will figure out where the problem really is. Now, if the board is too dark, I need some information to say that it is too dark. But if I put all of the lights on the board, what is going to happen? Good evening, for those who are just getting in and saying good evening. Good evening to you too. Right, I think that part is going to give way. When it gives way, then see, that's the side that is brightening up. And that's the side that the glare is going to cause you to not be able to see. So I think that is the end that I need to fix. And believe me, I will fix it. I know what to do. It's just that I don't have the time right now. Now, as I said before, let me know if the screen is dark or too dark. I'm also monitoring it on TikTok. Now it is down. It is down, and it is not so bad because there's no glare shining back at anyone from here. It is just that the light that we have right there, that light, I think that we need to maybe damp it a little bit so it doesn't give this bright glare in the corner over here. That's what I'm going to do. So apart from that, we may go straight ahead. Now today, for everyone, both new and traditional, yes, for both new and traditional, today is a problem-solving day. That means we are going to solve the problems. Now, we are going to choose a variety of problems. We like to take the homework problems, if we have any, and solve them. Students all, please, at the end of factorization, no one, I don't think that's since my entire career started, that students have been privy to so much information. First of all, during factorization, I've never posted any videos, students. I don't post videos during factorization. But now, I'm posting 77 factorization videos on TikTok. So if you let them get away from you, you're going to be in serious trouble. So at the end of this, no one should say, Mr. James, I do not understand how to do it, because guess what? everything is broken down. Because I had time to do it when I had the time to do the video, and then you have the time to watch the video 10 times, 15 times, 20 times. And they're all available to you on TikTok. So you should be well equipped for factorization. The videos that I'm uploading now are basic factorization, and there are 21 of them. I think that I have maybe 11 left. Is that it? It's surely not 6. Maybe 6, yes? Maybe it's only 6 that I have left. But there are 21 of them on basic factorization. Students, go and watch them. And watch them again and again. Alright, so our homework is on the first part of it, 3 problems on basic factorization. I don't think that anyone should be alarmed because we did quite a few of them in class. And additionally, I am uploading, in the process of uploading 21 of them. But I'm just giving them bit by bit. I'm not doing all at once. Now, the homework had 3 of those, and I'm going to put them on the board immediately. Which book do I use? I want to use my old book. Yes, here it is. There are some cases in which I cannot use this old book, but I think that I can use it now. So yes, the homework contains the even numbers that you are required to do. Yes, the even numbers. So what do I say? U squared minus 10 u squared v plus 15 u v squared. I hope that you are able to see that. Okay, thank you very much. Thank you very much. I'm getting the feedback to say that it looks okay. Well, if it looks okay, then it's going to be even better when I get the next glare out of the board. Okay, so good evening again. Concerning City and Guilds, no, I do not teach City and Guilds mathematics. I am just doing some work with the CXC C-Sec students, and that's all. But I'm sure that we have modules inside here will help you with the City and Guilds, especially the one that we are going to go to when we are finished with, yes, the one that we'll go to when we are finished with algebra. We're never going to be finished with algebra, but when we are finished with that module. All right, so let us go straight ahead. All right, let me put all of them on the board together. So I think that since that is fine, I will put the other one below it. V0 plus V0 beta t. If it sounds like Greek to you, it is because it is Greek. V0 plus V0 beta t. The common Greek letter beta. So let's go. Okay, this is 4. So this one is 2. This one is 4. And I'm going to put 6 here. Let's see what we can make of that. A cubed plus, no, it's minus a squared plus 7a. I'm just looking over there with the intention to go and fix it. So let's go, students. What is the common factor in this, this, and this? Of course, we see 5, 10, and 15. What do we choose? Students, there's a little bit of delay, so try to go ahead of me. We have 5, 10, 15. What is the highest common factor? There is 5. Thank you very much. All right, excellent. Now we're going to be looking at the u's. So we have u squared. I hope it's u squared I have and then u squared. Yes, I have. Or, that's not what the homework says. 5u cubed is here. So you have to adjust your approach now, students. So it is 5u cubed minus 10u squared v. Right. So that's it. So I'm going to give you a few seconds to adjust. So it is 5u squared minus 10u squared v minus 10u squared v plus 15uv squared. All right, so let's go again now. U, exactly, so we're going to have, the common factor is 5. U, any v? We have a v squared here and we have a v. Why is it that we're not taking v as one of the common factors? Sorry, as being a part of the common factor. One says u squared. Look at this. We have u cubed. Look, we have u cubed, we have u squared, and we have u. The u squared it would not be a common factor because it will not divide into the u. So that u right there, this one, prevents us from taking the common factor as u squared. Changing the u squared to u cubed there did not affect the common factor because we still have the u here, which means that we cannot use u squared as the common factor. What about v? V is not present in all. Because v is not present in all, yes, thanks, good. Because v is not present in all, it is not a part of the common factor. So let's go. What will happen first? Now I want the answer for this. V will cancel, sorry, not V. 5 will cancel 5. So the 5s will cancel, and u into u cubed, that's you're going to give me that one. U into u cubed. U into u cubed is u squared. Minus 5 into 10, u into u squared, and so on. Students are not going ahead of me. I get the u squared? No. 5 into 10. There it is, yes. 5 into 10 is 2. Then u into u squared is u into u squared. Students, there's a little bit of delay, so you have to go ahead of me. U. So u into u squared. What about the v? What about the v? There's nothing in the common factor. There's nothing in the common factor to cancel the v. The v will therefore go back as it is. And of course, I expect to see the answer by the time I look at the screen. 5 into 15, of course. Yes, thank you. See, there you have the v. Students, you'd have to go, right, go ahead of me. 3. So 5 into 15 is 3. Notice now the u will cancel the u completely, and then there's nothing to cancel the v squared. So because there's nothing to cancel the v squared, we have to have the v squared right there. Now, some students are asking me, what is this? You don't have to know what it is. All you know that this one, which we know to be the common Greek letter beta, is a symbol. It's a symbol. And we see the V0 there also. The V0 is a symbol also. And you know when you're factorizing, you should take the common factor. So in the two terms, you have two terms, this one and this one. What is common in the two of them? Because you have to take the common factor. So it doesn't matter what it is. It doesn't matter what it looks like. Because if you're solving a problem, you will see symbols in the problem that you don't know what they represent. But you know that if you are required to simplify or factorize, you know that you need to take the common factor if you are factorizing, and then that you need to divide each of the terms by the common factor. So it doesn't matter what it is. So in this particular case, what is the common factor there? The common factor is V0. So you take V0 as the common factor. It is present right there in all of them. And then what do you say? V0 into V0. Everybody will know what V0 into V0 will be. Anything divided by itself is 1. So V0 into V0 is 1. And in the next term, the V0 will cancel the V0, and all that will be left is beta t. So it doesn't matter what it is. It doesn't matter what it looks like. It is the same concept. It's the principle that you're applying to your factorization. And let us finish up with this one. What is common in this one? This one is kind of analogous to the first one. Yes, it is. There's an analogy between the first and the second. You can solve that by analogy. What is common in this one? A is common. Right, just like how you have u cubed, u squared, and u, you have a cubed, a squared, and a. Solved by analogy. So the common factor is a into a cubed. And by the time I ask, yes. What? A into a cubed is 3? I don't think that you meant that. A squared. All that we are saying, when we say a into a cubed, this is all what we are asking, you know. That's the same thing that we are asking. So this one is going to go over this one, and one of this one is going to cancel with the other up here. So that will give us a squared. What about this? What is a into a cubed? Sorry, a squared. What is a into a squared? You have to divide each of the terms by the common factor. I see somebody saying this too. When we say a into a squared, it's the same thing as putting a squared up there and a under there. And we have two occurrences here. And one will cancel one of those, and we'll just have one left. Plus, what will happen there? A into 7a, the a will cancel with this a, and 7 is the answer. Excellent. Please, students all, ensure to watch the audio visuals. Okay, so in a few seconds, I'm going to place the, yes, in a few seconds, I'm going to place the factorization by grouping problems. Yeah, because you know that that's the one that we're going to go to next. Factorization by grouping. I'm wondering if the board is too dark now. I still know what the problem is. Okay. All right, thanks. Yeah, because I have to be smothering the light. I have to be smothering the glare. And then when I do that, I still have the one right over there. If I stay here, I point right there. But now it seems to be that one, is it? No, it's that one. So, why is it? No matter how much I try to smother the glare, I know exactly what the problem is with that one. The light cannot shine away, and that's the difficulty that I have. I'm going to see how I can get it to shine away. And then I'll have that covered. But what I'll do, I'll put the factorization by grouping there. Yeah, I know exactly what is going on with that light. I know why. I know why the other one is not giving that glare. But that the other one is, I'm sure of it. Alright, so let us do numbers 2. We have 2, 4, 6, 8. AB 3y minus 1. Bread. Minus CD 3y. Minus CD 3y minus 1. Nice. I'm going to go to number 4. Number 4 is very nice also. WX minus WY is plus minus VX minus VY. Now, of course, the first one is not going to give us much of a problem. Okay, thank you very much. Yeah, thank you very much. I'm still seeing that the board is fine. Right. Okay, so we're going to be doing your factorization by grouping, but as you can see, that one is already done for you. Because it is halfway through for you, you're going to take the common factor. Remember now, we have to take the common factor, and the common factor turns out to be 3y minus 1. And we have to divide each of the terms by the common factor. So when we divide the first part by the common factor, this will cancel with this one, and what will be left is AB minus CD will be left. Because we're going to say this one will cancel with this one because we're dividing again, so we'll have minus CD. I don't want anyone to imagine that we just wrote the answer down because of some illogical reason or the other. What's the next one? Okay. For this one now, we have to begin at the beginning and take the common factor of the first two. And the common factor of the first two terms is W. Because you can see that W here and W there. Then we divide this term by W. When we divide this term by W, W will go into W and we will have X left. How so? Because it's actually WX over X. And then this will cancel that. Then also W into WY. The W will cancel the W. And we have a plus y right there. Next, we are going to use the sign that begins the second term. This thing here, which is a negative sign. And then after the negative sign, we take the common factor. So what's the common factor? V is common. V will cancel V and the X will be left. Negative into negative is positive. And then V into Vy, the V will cancel the V and you will have the Y left. Exactly. Now, what is the common factor? We have another common factor now. And that factor turns out to be one is saying is Y, the other is saying is Y. Come on. Among the other common factor is what? X plus Y, because it is common in all. Know that it is present in this term, it is present in that term. And what will it be in the next bracket? This will cancel this, and the W will be left. Then over this side, this will cancel this, and the V will be left. And that is how we get that in the second one. 6. That's nice. 2xy minus, is it? 4xz plus 3wy plus 3wy minus 6wz minus 6wz. Okay. Alright, I know what to do to cause this not to go into it. So what's common in these two? Surely what is common there? In the first two. What is the common factor of the first two? One is saying that is x. What is common in these two? Of course, you can see that for the 2 and the 4, 2 is common. X is also common there. And there's nothing else that is common. So the 2 is common. 2 is a common factor of 2 and 4, and the x will be present there. So what will happen here? The 2x will cancel the 2x and we'll have y. Then what do we have next? 2 into 4 is 2. And the x will cancel the x, and we will have z. Sign that begins the second pair. What's common? Surely 3 is common in 3 and 6. 3 is common. Then here, of course, no doubt that the w is common. Then what will happen? The 3w will cancel the 3w. Y will be left. Then 3 into 6 is 2. The w will cancel again, and all that is left is the z. And surely you can see y minus 2z Okay, so y minus 2z, that's what I like, students. Go ahead of me. And then what do we see next? This will cancel with this, and you'll have 2x plus this will cancel with this, and we have the 3w. Because that's what factorization is about. Taking the common factor and dividing by the common factor. 8. What do we say for number 8? Some students rearrange it. I'm not rearranging it. W squared x squared minus x y z minus w squared x some students would rearrange that. But as long as I can go straight ahead and factorize, I will not rearrange it. Rearranging it might turn out to be a little bit more convenient to some students. Go ahead and do it. Right? Yes, go straight ahead. So what do I say now? Apart from nothing. The common factor here, no W, no Y, no Z. The only common thing is a single X. X squared here and X there, so you take out the common factor of X right there. That's all. Of course, there's nothing to cancel the W squared. W squared goes back. X into X squared is X. And surely what is going to happen next? The X will cancel the X and we have YZ. And of course, your favorite, begin the next pair with the sign that begins the next pair. So it begins with a negative, we have negative. And of course, we look there, no surprise. There's no common factor that we can see, so we'll have to choose. Well, tell me the one that cannot work, and I will take a second look at it. Yes, the common factor is 1 in that particular case. So in this particular case, we are going to take 1 for the common factor. And of course, you know that 1 into anything will give you the same thing. Then of course, you cannot forget, negative into positive is negative. And there's nothing else to cancel, so the Y, Z will go back. And of course, you can see your common factor to be W squared X minus YZ. And what will happen? This will cancel with this, the X will remain. And here again, the common factor, we are dividing by the common factor, will cancel with this one, and we have minus 1, and that's all there is to it. Right, so that's nice right there. There it is, still peeping out of the corner of its eye. The board is okay, I admit that. So I'll be working along with you with that board, but it's just that glare that is right there. I'm sure that you are seeing the board where I write and everything, but that one over there is the one, is the culprit. No matter what you put on it, it's still showing over. Because the filament is exposed. Right, but that is not too bad, so we'll continue. Now, students, we'll go back to our regular tutorials until next week. Because next week, we'll have a lot more to do. A lot more problems to solve. But, take your tutorial one book. It looks like this. Mine is crude. So this is tutorial one book. Yes. So for the YouTubers there, and for the TikTokers, right down here. Right. Right, so that's wonderful. Tutorial. And yes, tutorial one. That's the one that I'm going to be working from. Students, my numbering might be different from yours, but surely you will find the problem right there. So go to decimals and see what we can make of it. Now, students, presently, what we are seeing now is that you are able to, this is the book. See, what we are doing for the tutorial, you know that the tutorial is a problem solving. The Sunday evening is a problem solving session, students. So all that we do on a Sunday is solve problems. Now what I've just done, I've just solved the problem from the algebra homework. So the topics that we have covered already, the homework that are appropriate are basic factorization and factorization by grouping. Yeah, so that's basic factorization and factorization by grouping. Now that we have completed the ones that we intend to do as homework from the algebra book, we are going to go back to our regular tutorial book because we have to solve problems for the entire year on this Sunday evening class. Because the Sunday evening class is what kind of a class? It's a problem solving class. Let's go. We're going to go to decimal. Students, please help me. When I put the thing on the board, I'm going to attempt to work them out in my mind alone. Right? So I'm going to look at your response. Yes, I'm going to be looking at your response for confirmation. Right? So I'm not taking this thing up on myself alone. I want you to be an active participant. Yes. 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 This is the real book for the Sunday class. It's just that because we are doing other topics, we are doing topics, so we are doing the solution in the Sunday class for the homework also. But this is your real book. This is a tutorial class. Yes. Anything that has to do with the solution of problems. All right, let's go. Yes, this is the next one, which is another one. We're not going to be going too distant. We're going to be doing the tutorial using this book and the algebra book, nothing else for now. And except on Tuesday, and you know that Tuesday is the accelerated class. Yes, except on Tuesday, and you know that Tuesday is the accelerated class for those who are doing the examination in January. So, let's go. Decimals. G. Alright, so students, decimals. Let's go to the first one. And of course, I need your support. Because I am not using a calculator. I need your support, students, because I'm not using a calculator. Alright, so let's go. Number one. .5 plus 2.85 over 4.66. I'm going to put the point big so that it does not just look like a stray spot on the board. 4 minus 3.21 minus 3.21. Yes, sirree. What is that equal to? That is equal to, my guess is 4.35. I don't see that on the screen as yet, you know, for the students. All right, I'll continue. Tell me if you get it. 1 from 6 is 5. 2 from 6, that's 4. So 1 from 6 is 5. 2 from 6, that's 4. 3 from 4 is 1. Yes, students, I'm not using a calculator. Sir, that's the next book. Yes, it's the next book. Share the live. Okay. So let's continue, students. Is that okay? So I have to do that in my mind. Yes. No, students, let us not spend the entire evening on this one. Just by looking at this, I am going to guess that 4.35 is 1.45 multiplied by 3. Yes, I'm going to guess that it's multiplied by 3. Students, these problems are quite a few of them from the olden days, when mathematicians used to be smart. Well, mathematicians are still smart, but we just have less mathematicians around. Now, if we are simplifying this, in the days of old, we imagine that it's going to turn out to be a nice rounded figure. If this is going to turn out to be a nice rounded figure, then 3 should be the only answer. But we cannot take it for face value. We're going to say, all right, that's a guess. A guess is not wild. A guess is intelligent. A guess is calculated. So when you make a guess, you're not making a guess like, no, that look like 50. Just say 50, man. Just say 50. Because we just want Mr. James to stop asking the class. So say 50. Because if Mr. James hear an answer, he will stop asking. Say 85. And let him stop talk. Now, yes. So 4.35. We can check if it is 3 by doing this. 3 5s 15. 3 4s 12 plus 1, 13. 3 1s 3 plus 1 is 4. So we know that is the correct answer. So we just simply write it down. I'm going to write it beside it. Take this equal sign and just equal 3. Done. Number 2. Do we go to number 2? We should be just doing the odd numbers. Yay! This is a nice one for you, students. 0.432. What I'm going to be doing here, students? Yes, what I'm going to be doing here, I learned this in primary school, not high school. 0.02 over 0.024 over 0.024. Yes, students, I learned that in primary school. That's where I learned it, primary school. Yes, that's where I learned it, primary school. So what do I say? You look for the number of decimal places that you have in the numerator. How many decimal places do we have in the numerator? 1, 2, 3, 4, 5. You're counting the number of digits, the total number of digits. Yes, thank you. That's correct. All right. So yes, you're not going to be counting only. You're not counting only this one. You are counting all of them. All of the decimal places. That means all of the digits that go after the point. 1, 2, 3, 4, 5 in the numerator. And we have 1, 2, 3 in the denominator. Right. So that's it. We have quite a few there in the numerator and also the rest in the denominator. So if we are going to clear all of the decimal places, that's what we use. That is one method that we used to use, where we clear all of the decimal places. We clear all of the decimal places. Now, we need to clear 5 decimal places in the numerator and also 5 in it. Since we are clearing 5 here, we have to cater for 5 here. But we do not have 5. So you know what we'll have to do? We'll have to make the necessary adjustment. Right, so we'll make the necessary adjustment. So what do we do? What do we do? We clear all of the decimal places in the numerator, so we'll have what? 432 times 2 over. For us to get all of that, we have to clear 1, 2, 3, 4, 5 decimal places. Here we only have 1, 2, 3 to clear. So when we clear 3, we'll have 2 left. So to clear 3, we will have 24. And we have 2 left, so we have to include placeholding zeros. So that is the arrangement that we have right there. And what do we do next? We will simplify. And you know, when we are simplifying, we take the largest factor that we can possibly find. You want to take 24? Of course, you need to be able to split your numbers in terms of place values. So that you have the 4, which is 4,000, which is a multiple of 8. 4,000 is a multiple of 8. And then we have 32 here, which is also a multiple of 8. So if you wish, yes, if you wish, you can take it out like that. Not only that, but if you study mathematics, you'll realize that we have 4 plus 3 plus 2. We don't even have to add them because they are 3 consecutive numbers, 2, 3, 4. So that's a multiple of 3. So it is a multiple of 3. It is a multiple of 8. It is therefore a multiple of 24. So 24 will divide into this and this quite easily. But what we could do is just take them one at a time, just to get it down smoothly. So what do we say? 8 into this. And 8 into this is 300. Then what do we say? 3 into 54 should be 18 times. And 3 into this is 100. Now students, common sense is greater than mathematics. If we bring it down to that, we don't have to simplify this further. Because if we simplify this further, we're going to get something like 2 will go into this is 50 times, and then 2 into this is 25, and then 2 into that is, so you're going to get 9 over 25 students. If you work that out, you're going to get 9 over 25 that you need to convert to a decimal fraction. But if you do it like this, 2 times 18 is 36. And then you will say 36 divided by 100 is the same thing as reducing 36 by 2 places of decimal. See what I'm talking about? 36 over 100. That's what you're going to get. And there's nobody inside this classroom who would not see that as 0.36. So it will turn out to be 0.36. But that is for the general public. For my particular students, you will see this irrespective if it is what? 9 over 25 also. If it is 9 over 25, my student will see it nonetheless. Why? Because my students know that 4 and 25 are converse numbers. Right? 4 and 25 are converse numbers. So if somebody say divide by 25, you multiply by 4. So you're going to say 9 divided by 25, you say 9 times 4 then. And when you get the 9 4 is 36, it's the same thing, 0.36, and you can use your calculator, divide 9 by 25, and you're going to get 0.36. You'll learn more as you go along that 25 and 4, they are converse numbers. So if somebody asks you to divide something by 25, you just multiply it by 4. And make the adjustment, and your answer, you'll get the correct answer. So if somebody asks you what is 16 divided by 25, you just say what? 16 times 4 is 64, so it's 0.64. Students, do not write loose number and loose decimal fraction. If you write 0.36, that's a loose decimal fraction. You need to write 0.36. Alright, so you learn a little bit of mathematics right there. That 9 and 25, 4 and 25 are converse numbers. Students, keep your calculators nearby because I might need your help. So let us move merrily to number 3. Oh, oh yeah, we see number 3 and there's a big part B to it. You're going to use your calculator to give me the part for point B. Evaluate without a calculator. I like that. Evaluate without a calculator. Students, I can't ask you for help here unless you're going to give me the help without a calculator, because this one says evaluate without a calculator. So let's go. 1.02 to be multiplied by 0.14 all over 0.7 times 50.1. 50.1. So we see that it's part A of number 3. If number 3, I'm going to put my finger near to it. 10.02 times 0.14, 0.7 and what? 50.1. That's nice. So students, no calculator according to the requirements of this problem. Let's go. Students, I'm going to clear the decimal fractions. So we count the numbers that we have here. 1, 2, 3, 4. So we have 4 decimal places here, but we have only 2 down here. We have what? 4 here and only 2 there. So what do we do? First of all, let us clear the numerator. So we're going to have 1002 times 14 over, what are we going to do? Students, we have 4 decimal places. We can put 2 here and 2 here. We can put 1 here and 3 here, or the other way around. And we can put all 4 of them in any one of them. Alright, so maybe the best is 2, 2. So let us see if 2, 2 will work. Or, well, let's use 2, 2. I don't think that we since we have that, we have 1, 2, 3, 4, but we only have 1, 2 here. So I think I'm going to put 2 on this. So if you're going to put 2 on that, you have to put the 7. And the 7 is not enough, so you have to put another 1 times here. Notice that we only have 1, so we have to put another 1. So 50, then the 1, and then the other 1. You have to use a placeholding 0 right there. And students, whether they say evaluate using a calculator, see, I'm showing you, and for the most part, what we have done already, this is something that I learned in primary school, so I'm sure that you can see that portion of it. And of course, if you look, just keep your eyes open. How do you mean how? If you keep your eyes open, what do you see here? 5 2s, 10. 5 1s, 5. So you can see that this that we have here is merely 5 times that. See? 5 2s, 10. And then you're going to have it 0 here. And then 5 1s, 5. So this what we have here, you can see that this is just for 1 and this goes out 5. There's no problem. So you see there, that's what we have. Any more? Yes. I think that we could leave this 5 and 4. Okay, that's fine, right? So what we could do is 14 into 14 is 1 and 14 into 70 is 5. So what we have there is what? 1 over 25. And you know the answer for that already, students. You know that 25 and 4 are converse numbers. 25 and 4 are converse numbers. So 1 divided by 25 will be the same as what? 1 multiplied by 4, which is 4. Yes, see, somebody put it is here. Yes, student, it's 4, but it's not just 4 because you have to make the adjustment. So it's going to be 0.04. When you get the answer, you have to reduce it by 2 places of decimal. So the answer is going to be 0.04. That is how you use your converse numbers, students. This one said that you should use your calculator. See? Let me see. We are at number 3. Use your calculator. Square root of 0.749. The square root of 0.749. They say use a calculator. What do you get when you use a calculator, students? I can't find my calculator. Oh, there it is. .865. Don't give them more than 3 decimal places. 0.865. So it is right there. All right. So let us take on another one. There are some of them that I do not like. Number 4. Whew. And it says, number 4 says, without using a calculator, calculate the exact value of. You know what that means, students? Do not use a calculator. Let's go. That means I cannot ask you to use a calculator. I only can ask you to use your brain. So let's go. 0.28. 0.28 4 minus 4 minus 2.95. 2.95. That's nice. Over this. 0.7 times 0.14. Now students, when you see a problem like that, don't approach it brain dead. Approach it like you can see what's up right here. And you can see that what do we have? A 28, a 7, a 14. So you know that we are moving along, merry along, with factors of 7. Sorry, multiples of 7, yes. And factors of 7, because we are looking at these numbers to be multiples of 7, therefore we want factors of 7 to simplify the expression. But they say don't use a calculator. Students, 4 minus 2.95 is like 95 from 100. And that is going to give you 5. So it's going to be 0.5. So this is 4 minus 2.95 is going to give you 1.05. So we're going to have this now. 0.28 times 1.05 over 0.7 times 0.14. Now students, the first thing that you should be guessing is that 105 is a multiple of 7. $1.5? I think it's 1.05. If you want me to take a second look at that, then I will do that. 0.86, 0.8645, 0.86. Yeah, because if it is 8645 and I'm rounding it off to 3 decimal places, then of course I'm going to add 1 to the 4 to make 5, if so be the case. If I'm running it off to 3 decimal places. If I'm running this off to 3 decimal places, it surely would not be 0.864. Don't worry, students, if you don't run the number up before handing it to me. They have a thing in information technology known as truncation. And truncation is a normal thing for variables. Right? Okay. See, I see this thing right here. No wonder. No worry. I'll soon get the better of it. I know what's causing that problem. It's just that the light cannot be turned all the way around like the other one. Alright, so let's go, students. What do we do with this? This is equal to 28 times 105. I'm going to get my head out of the way. Over, see? 1, 2, 3, 4 decimal places. Now we only have 3. 1, 2, 3. So since we have 4 in the numerator, we'll adjust the denominator by 2. 2. So 2 and 2. Right? So 2 plus 2 is 4. So I'm going to put 2 over here and 2 over there. So in order to put 2 over here, this only 1, the 7 has only 1, so we have to put another 1. So this will turn out to be 70, the culprit from last problem. And of course that will turn out to be 14. And students are very happy when they see the 14 right there with the 28. But they will just be hanging on for a few seconds to determine if the 105 is a multiple of 7. Of course it is. The 105 is a multiple of 7. It's a multiple of 35. It's a multiple of 5. So that can be simplified quite easily. Right? So what do we say now? Apart from nothing. Of course, you might want to take out the 14 very quickly and put a 2 there. And maybe, if you look at that 70, you'll have a 2 times 35. So this problem will go without a decimal fraction. Because if 2 into this is 35, so 2 will cancel with this, and 2 into this is 35. And then 35 into 105 is 3. Right, so 35 is 3 times 35 is 105. So let's work that out. This is equal to, what should I do first? Do this. 2 will go with 70. 1 time and 35 goes there. Students, 105 divided by 35 is 3. So your answer is simply 3. Right there. Yes, thank you very much to confirm that the answer is 3 before I got there. All right, so we are back over this side. And what do we need? What do we need? To continue with numbers 5. I'm happy that number 5 did not say use a calculator. So that we should not use a calculator. But students, that's what we used to have in the olden days when we were required to solve problems without using a calculator. And is this significant now that you can use a calculator? Yes, it is significant because sometimes I see a few sophisticated calculations in the multiple choice examination. Right. Sometimes I see that a few sophisticated calculations in the multiple choice exam. Right. Right, so I'm leaving that one on there just for a few seconds. Alright, so let's continue from number 4. We're going to have some more fun with some of these. And some of them, notice that some of them did not say that you should proceed without a calculator. It's just that I am demonstrating how some of them may be attacked and defeated without using a calculator. And I'm at number 5. Alright, so let's go. They say find the exact value of this. So we have 2.55 times 3 is, I think it's 6.3. 6.3 minus 7.5 over 1.25. Now students, we guess that, well, the first guess is that this number, the 7.5, is a multiple of 1.25. It's an exact multiple of 1.25. That's the first thing that we'll guess. Why do we guess that? We guess that because mathematicians used to set problems when they are dividing like that, they give you numbers that will work out quite easily. So we are thinking that. So if we are thinking that, what do we say then? Is it 1 time? No. 2 times? No. You know that 2 times will be just 2.5. 3 times? No. 4 times. So you start to think now, 4 times. 4 times the possibility. But we're going to have what? 4 ones 4. And for us to get a 7, we would have to carry a 3 from there. So we know it's not 4 times. Students, it has to be what? 6 times. It cannot be 5 times. It cannot be 5 times, students. Why cannot be 5 times? Because if you do this, 1.25, and you multiply that by an odd number, if you multiply that by an odd number, you are going to get 2 decimal places for your answer. The only way that you only get 1 decimal place for your answer if you are multiplying by an even number. And the even number must not be a multiple of 4, because if you multiply 0.25 by 4, you're not going to get any decimal fraction. You're not going to get a fractional part. So if something ends with something 0.25, which is a quarter, you know that if you multiply that quarter by a multiple of 4, then you will not have any fraction. Because you're going to be multiplying like 0.25, which is a quarter, times 16, or 12, or 4, or 8. So you're not going to have any fraction. Or you can see it like this, that 0.25 is 1 over 4. And if you multiply by any multiple of 4, like 24, the 4 will cancel and go away, and then this is going to be 6. So we're going to have a whole number. So whether it is whole number, or it is vulgar fraction, or it is decimal fraction, the principle applies. It cannot be 4 times. And it cannot be an odd number time, because if it's an odd number time, you are going to retain 2 decimal places. So it has to be 6. So I'm guessing that is 6. 6. Let me try it. 616. Let me see this. 75. So 6 times this. 6 times a quarter is 1.5. So we are going to put this 0.5 and carry 1. And then 6 plus 1 is 7. So if you try it, you should get something like that. Somebody confirm that with me, please. That if I divide 7.5 by 1.25, I will get 6. Or we can just multiply it. 6 times 25 is 150. Put the 50 and carry 1. 616 plus 1 is 7. Thank you very much. I'm losing my head too, so you have to help me, please. Students, why do you think the examiner does that? The examiner is trying to see if you are going to subtract the 6 from the 6.3. That's why the examiner did that. Yes, the examiner did that to see if you will the examiner is doing that to see if you will take the 6 from the 6.3 and then multiply by 0.3. That is why it is doing like that. But what you should do first is multiply this by 6.3 and then minus 6. Do it in one step, students. Don't give me 2 steps, because they said that you should use the calculator to do it. Let me see if they say that you should use it. No, they did not say use it, but they did not say don't use it. So we'll have to multiply 2.55 by 6.3. 2.55 times 6.3 minus 6. I'm going to put that in the calculator. 10.065. 10.065. After 10.065, they might want you to do what? To write the next part of it. This is part A of number 5. And the part B now, you are required to write this correct. Write your answer correct to 1 decimal place. So you need to write that correct to 1 decimal place. For 1 decimal place, let us write it again. 10, I'm going to erase it in a minute. 10.065. If you want to write that correct to 1 decimal place, you need to go right there. Decimal place number 1. Then you check this one. If this one is 5 or more, you add 1 to this one. So because this is a 6, you add 1 to the 0. So it's going to be 10.1. 10.1 is your answer. And they are telling you for number 6, strictly without using a calculator. That's nice. Let's go. $26.32 plus, I have to use plus, 38.8 all over 13.16 minus 11.56. 13.16 minus 11.56. Very nice, man. Let's see what we can make of that. So when we add those together, the 2 will go back. I should write it down a little bit lower. When we're adding these, the 2 will go back, and 3 plus 8, 11. So we'll have 1 there, a 2 there. Do not forget that we are carrying 1. So we are carrying 1. 8 plus 6 is 14, plus 1 is 15. And then the others will be added. The 3 with the 2. And that will give you 5. And the one that we carry will give you 6. And that is all over this minus this. So we'll have a 0 there. 5 from 11 is 6. 1 from 2 . So students, confirm if this is 1.6. So please confirm these answers. 65.12 and 1.6. Come on, students, I was asking you for the longest while to confirm that this is correct, that I'm dividing 65.12 by 1.6. Thank you very much. So this one is equal to we are going to clear the decimal places. So the decimal places are 2 here. 1, 2. And we're going to clear 2 here, but we only have 1, so we put a placeholder in 0. Now, let's see how far we get with this 16. Surely 16 can go into 512. So we don't have any problem there. 16 can surely go into 512. But if it is 16 can go into 65, then there's where we're going to have the difficulty. But we can take it right through. 16, 4, 64. Let's go. Let's take it out. Do not forget that we are not crossing the 0. 16 into 65 4 times. 4 times and carry 1. So it is going to be 11 now. 16 into 11, I can't. But let's see if 16 will divide into 112. Let us see if 16 will divide into 112. Is it 112? Let's see. Carry 1 into 11, 0, and then 16 into 112. Let me see. One student say 7 times. Okay. Yes, you're right, student. You're right. You're sharper than I am, you know. Because let me show you how we do it, students. It's just that, yes, you beat me to it this time. But let me show you how I would do it. And I was just, maybe just a little bit off. Let me explain what we do. If we want to know if 16 can go into, let me show you, like over here. If we want to know if 16 can go into 112, what we do is, we take the 6, and we say 6, 1, 6, then 6, 2 is 12. So this will end with a 2, right? But we know that it is not 2, and it's not 12, and it's not 22. So we continue multiplying. So it's 6, 1, 6, 6, 2 is 12, 6, 3 is 18, 6, 4 is 24, 6, 5 is 30, 6, 6, 36, 6, 7 is 42. So because it ends with a 2, our next guess will be 7. Yes, so our next guess would have been 7. And of course, you are right on it. There. So, 16 into 16 is 1. Do not forget the 0. So your answer will turn out to be what? 40, because it's dividing by 10. 40.7 is your answer. Your answer is 40.7 for that one. Right. So your answer will be 40.7. That one took me too long for comfort. Seven. .03 times 1.3. Now students, this one is pretty straightforward. If you're going to be doing that, what do you say? That is equal to 13 times 3 is 39. 13 times 3 is 39. Then you have what? 1, 2, 3 places of decimal. So it's going to be 1, 2, 3. So you have to put a 0 here to get your 3 places of decimal. You have 1, 2, 3 places of decimal. So you'll have to put a 3 there. Sorry, a 0 here to get your place of decimal, and then this is going to be your answer. Because your answer is required to have 3 places of decimal, like the total number of decimal places of the numbers that you are multiplying. Thank you very much. Somebody's ahead of me on that one also. Now this one, 6 to be multiplied by, this is the Roman 1, Roman 2, 6 to be multiplied by 3 minus 1.47. And we know what 3 minus 1.47 is. 1.53. Right, and then you multiply. 6 3 is 18. 6 5 is 30 plus 1, 31. 616 plus 3, that's 9. So that's your answer, 9.18 when you multiply that. One of your favorites coming along, number 8. What does number 8 say? 1.69 times 1, so 10 to the power of 4, all to the power of a half. That's nice, students. That's very nice. Now, students, this is not just merely manipulating decimals, but you can see the indices there. So decimal combined with indices, and you realize how important it is for you to internalize every topic that we have done so far. Yes, internalize every single one of them. Now, students, in indices, we have 2 things that we should do here. One, some students, let me tell you what some students will do here. Some students will attempt to take the half as an index to multiply the entire thing, which is correct if you can work it out, because there's an index of a half here. But the student who is able to be more flexible to see that the power of a half is also the square root, and then from here you have a number with an index that is raised to another power, so you're going to multiply the indices. So do not forget that the half is the square root. The half power is the same thing as the square root. So you're going to have the square root of 1.69. You could also write the square root of 10 to the power of 4. But you would not want to write that. You want to be more flexible. So you want to say 10 to the power of 4 to the half will be what? 10 to the power, and then you multiply the indices. Because when you have a power raised to another power, you multiply the indices. And of course, no problem seeing what? 1.69, the square root of 1.69. It looks like 169. So someone who says 1.3. Yes. So this one is 1.3. And of course, when you have what? To the power of 4 times to the power of a half, you're going to multiply 4 times a half. A half of 4 is 2. 10 to the power of 2. Now, of course, this is in scientific notation, which might be what the examiners want, but let's see what they want. Calculate that. They just want you to calculate it. So if it's a matter of just calculating, you could just put what? Nothing? What could you put? You're multiplying this by 10 to the power of 2. 2 zeros will be increasing by 2 places of decimal. It's 100 also. So it's going to be 1. Then it's going to be 1, 2. So it's going to be 3, 0. So the answer is 130. Students who have a ton load of zeros, students, do not forget that the power is to a half also. Yes, and I see someone saying it is 130, and I see someone say that we should use 10 to the power of 2. So you are correct, and you are 100% with it. All right. so what do we say? Do we move for more? Oh yeah, we have this beautiful one that we need to do because this is just a Roman one. I like the Roman 2 because it has the 0.09 over the 400. So let's do this. I'm looking right there to see if you should be able to see it. Alright, so you will surely would see that the square root of 0.09 over 400. Students, don't be overtaken by your square root and your indices. Right? Don't be overtaken by it. The square root of 0.09 is 0.3. So this is going to be 0.3. And the square root of 400 is 20. Right. I think that you could adjust the decimal places to 3 there. And maybe you could put 200 here. Well, I hope so. We have 0.3 there over 20. If we increase by 1 place of decimal, we increase by 1 place of decimal, there is no decimal place. So we say 3 divided by 2 is 1.5. Right? Yes, 3 divided by 2 is 1.5. Then we have what? 2 decimal places. 10 to the power of negative 2. Or if you please, you can still put it over 100 because it's going to be maybe better for your eyes if you do it that way. Maybe it's better for your eyes like that. And then what do you do after that? You're going to simplify by 2, you're going to reduce this by 2 places of decimal because you're dividing by 100. So that's going to be equal to 0.015. That is going to be your answer. Number 9, evaluate this. I'm at a loss as to figure out what they intended. Yes, I see the correct answer right there. I'm at a loss as to what they intended by number 10. Is it number 9? Yes, even number 10. These numbers should be done with calculators. Of course, you students, you're seeing that we're dividing by 0.7 there. And what we have there is not a multiple of 7. So you know that we're going to have a horrible looking eternal decimal. But let us do it nonetheless. And do what they say that we should do after. Right. So evaluate this one. 1.9. This is number 9. A. Oh, it's horrible. 1.9 times 10 to the third power over 7 over 0.7. And when we get the result, we square it. What would you do? I would just say 1 1.9 times 1,000 divided by 0.9. 0.7. I'm going to do it. I'm going to do it quickly. And I'm not going to write it in 10 different steps because of the horrible decimal that we're going to get. So I'm going to square it right away. I think I'm going to get the result, we should square it. So I'm going to do it all in one. I'm not going to write a finite decimal and then square it. I'm going to do exactly what they want me to do. So of course this is 10 to the power of 3. If you multiply 1.9 by 10 to the power of 3, you're going to get what? 1,900. After that, you know what they want us to do? They want us to square it. You see this horrible looking figure that we get? Express your answer in standard form. That's very nice, man. 7.367. No, it's 7,367. So it's 7,367, 346.939. 939. And that is because they can't go any further, because I'm sure that they have more decimal places. Then they want us to write that in standard form. B, express that in standard form. So to express that in standard form, we have to have what? 7.367, 367, 346, 346, 939, 939 times 10 to the power of, the decimal point is 7.3, so we know that it's going to be what? 1, 2, 3, 4, 5, 6 decimal places. So 10 to the power of 6. 1, 2, 3, 4, 5, 6 decimal places. So that will turn out to be 10 to the power of 6. We're not doing standard form as yet. We're going to do that next module. So next module we'll go in greater detail with that. The other one that we need to do is this one. Let's see what we make of it. We have number 10, part A. Number 10, part A, that says what we should do. Evaluate 0.023 over 0.351. Don't take a second look at that, students. Because the only way that will make sense is if we can divide evenly 23 into 351. And I doubt that very much. So it cannot be simplified easily. So we should just solve it the way that it is. Divide by 0.351. 0.02 give your answer to two significant figures. So we evaluate that and it turns out to be 0.065527. Is equal to 0.06. It has more decimal places. 5527. 5527. But that's the best place to round it off because a zero followed. And they say, write that. Give your answer in standard form, not that one. Give your answer to two significant figures. Give it to two significant figures. 0.0, 0.0665, 655. I hope it, let me make sure it's 6, yes, it's 655. 655. 27. And you're going to write that to two significant figures. Students, you will have to start off at the most significant digit. And the most significant digit is this one. So this one, the 6 that we have here, is the most significant digit. Then you're going to take what? Two significant figures. So you have to go to the you have to go to the two significant figures, the second one. So that one will be the second. So for two significant figures, that is where you need to go. When you get here, you need to check this one. If this is 5 or more, you add 1 to this. Because it is a 5, you need to add 1 to the 5. So we have what? 0.066. So the B part is 0.066, and that is the two significant figures. Students, I think that I don't know how many I have, but I have a lot of videos on decimal, working with decimals. So I could post those up also, but no, I'm not going to post those up. I'm going to work with the factorization. Because the factorization has what? A great far-reaching effect. Yes. All right. So what's the next one? Evaluate the following. And I'm going to attempt that without calculator. I think that number 11, when I do that one, you will be impressed with my answer. Alright, let me see if I can manage this one without a calculator. Let's go. 11 Roman 1. 11 Roman 1. 3.5 times 0.07 over 2.5 minus 0.05. 2.5 minus 0.05. Students, as soon as you see that, you think that they are giving you the problem away. So they have what here? 3.5 times 0.07 over I'm going to think is 1.45. So we're going to put the 0.5 here. Then when you do this, you're going to have a 4 there. .45 because nothing to remove that 4. So do I have that correct now? 2.45? No, I see an age-old figure on the screen. Alright, so let's go. If we write this as 35 times 7, and then I put this over, now, for me to do that, I will have to clear 2 decimal places. Sorry, 3. 1, 2, 3. So I need to clear 3 here. So when I clear 3 there, I get 2, 4, 5, 0, because we have the 3 of them. 1, 2, an additional 1. 1, 2, and an additional 1. Nice. Now, students, this is what I do, students. This is what I do. This is what I do, students. I remember when I was solving some problems just now, 105 came up. I know 105 to be a multiple of 35. Right? So if 105 is a multiple of 35, if I double this, I get 210. That's a multiple of 35. But if I take the 210 and I add 35, I'm going to get what? 245. I did that in my brain, students. And I know, therefore, that 245 is a multiple of 35. I know that in my brain. And I can guess how many times that it is 7. Well, of course, you know that this is 3. If you double it, this is 6, and then you add another one is 7. So you see that it is 7 times. So students, do not forget something that you just learned. Be prepared to always use some information that you have. Right? I would know, it would not be far-fetched for me to know that 105 is a multiple of 35, and as a matter of fact, it's equal to 3 times 35. But maybe if I didn't see the problem with the 105 today, it wouldn't click in my brain so quickly. But I just saw it a while ago. So because I just saw it a while ago, you can't say that it doesn't click or it shouldn't, because it should click in your brain also, because you just saw it a few seconds ago also. Correct? Yes, correct. So this answer, you should see, the students, that this is what? 0.1. You should see that is 0.1. Look at this. 7 5s 35. 7 3s 21 plus 3 is 24. 245. So 7 times 35 is 245. So you can take this out cleanly like that. And then if you take this out, it's going to be 10. So it's going to be 1 over 10, which is equal to 0.1. Dot. Students, in the olden days, that would not be far-fetched. Why? Because we expect teachers, textbooks, professors, everything will expect that the problems that will be given, we expect them to be problems that will give us a rounded figure. Yes, especially if we are required to do it without using a calculator, or maybe it's a dual problem. You may or may not use a calculator. Yes, students. It may be a dual problem, which you may or may not use a calculator. Now, of course, you don't imagine that I'm going to do the entire book or the entire topic on decimal, else you will have none to do. But let's continue to the end. What do I say? $125. Oh no. All right, so let's continue. Alright. This one that we have just done 11 part 1. This is 11 part 2. Roman 2. 32. This is not 32. 3.2 times 10 to the 4. 3.2 times 10 to the power of 4 Divide by 2.1 times 10 to the power of 3. Divide by 2.1 times 10 to the power of 3. No problem, students. The greatest problem that we have is that the numerator or the dividend is not a multiple of 7 or 3. So because this is like a multiple of 7 and 3, we know that the result will be horrible. So maybe we could just round that to 3 decimal places. So we're going to have what? We're dividing. And I think that the best way to look at this is like this. 3.2 times 10 to the power of 4 over 2.1 times 10 to the power of 3. And of course, you see what is going to happen here. That in the end, we'll just have 10 to the power of 1, which is 10. And that will be in the numerator. And then we're going to do 3.2 divided by 2.1. A horrible looking thing. 3.2 divided by 2.1. 1.5238. 1.5238 times 10 to the power of 1. Or just 10 if you want to write it like that. I don't think that they wanted to write it like that. I think they wanted to write it like this and then go back and write it again. So it's going to be 15.238. Because I don't know what that's for. Because they give you a part 3 that requires you to write it in standard form, which is the one that we just did a while ago. 1.5238 times 10 to the power of 1. Don't worry, students, that the decimals are getting the better of you in terms of you might not want to do them. Oh, I see some students that I would want to work out. I think that I'm going to work that out after this one. So that, let me see. Oh yeah, we have 4 minutes left. I don't think that I'm going to go over tonight. Alright, let's go. I see a few that I would want to work out before I go. This one. The square root of 0.0004 times 10 to the power of negative 6. Giving your answer in standard form, that's not bad. Students, if you know a little mathematics, you could see the square root of 0.0004. Why? First of all, it has an even number of decimal places. So you can take that hint that you can write down the square root of that because it has an even number of decimal places. Students, when it has an odd number of decimal places, you're going to have difficulty writing down the square root of that number. But you can see that if you square 2, you get 4. And if you double the number of decimal places, you're going to get 1, 2, 3, 4. That means half of the decimal places. So this part, the square root of this part is actually what? 0.02. And of course, you know that the square root is the half power. The square root is the half power, so you're going to take a half of negative 6. Remember, when you have a number with a power raised to another power, you multiply the indices. Thank you very much. So we're going to have what? Take half of this, half of negative 6. So 10 to the power of negative 3. But that's not in standard form. To put this in standard form, you have to write what? 2 there. And of course, you would have increased this by 2 places of decimal, or you can see that this is a small number, and it should be accompanied by a negative number, a negative power of 10. So 0.02, notice that we have what? 1, 2 places of decimal, So it is 2 times 10 to the power of negative 2, then times 10 to the power of negative 3, and you know that as much as you are manipulating decimals, in this particular case, you have to apply the law of indices. And what's the law of indices right there? You're going to add the indices. So students, when you add a negative 2 and a negative 3, what do you get? I see a negative 3. When you add a negative 2 and a negative 3, students, what do you get? I don't see any answer. When you add a negative 3 and a negative, I'm not going to wait anymore. Negative 5. So that is your correct answer. All right. Is there any other one that I want to do before I go? We're on the border of 8 o'clock. Students, you have a few more to do on your own. So, of course, take your tutorial books and practice. All right. What do I have? What do I know? What do I see? Gee, well, I have exactly 8 o'clock by my time. Students all, thank you for gracing me with your presence. Thank you for inviting others. Thank you for participating. Thank you for giving me correct answers to place on the board. Thank you for everything that made this class possible. Do not forget your mathematics resources. If you need to acquire them by any means, you can send me a request. And students, do not forget that we are doing factorization. Not only that we're doing factorization, but what? We are presently uploading we are presently uploading the audio visuals for factorization. And I am still at basic factorization. There are 21 of them. And let me tell you what is going on. I'm going to tell you, if when I go home, I'm going to put up any more. So yes, I'm going to take a look. I can just look and tell if I need to put up some more when I go home. Right? So students, at the end of it, you should not be able to say that you cannot factorize anything at all, because 77 audiovisuals will be loaded onto my page. Yes. There you go. Yes. All right. So when I go home, students, I will be uploading some more. Right? And then maybe by the end of the day tomorrow, I'm going to go over to factorization by grouping. We don't have 1,000 students. We don't have a lot of factorization by grouping. And then after that, we are going to go over to the difference of two squares. You're gonna even have more fun. We're gonna go over the difference of two squares. And then I think that we should finish factorization by next week, Monday evening. If not, by Thursday evening. Because of course we have 2 more instructional classes. Alright, so thank you very much. And it's time to say goodbye and have a blessed rest of the evening and a restful night. And when you see the hands go up, then you know that the end of the class is here. So Goodbye and see each other tomorrow afternoon. Good night.